Okay, so today we will be discussing chapter 3, representations of data. Okay, which means we are going to learn how to represent the data. In the sense, the first type of representation that we are going to learn is histogram. Okay, so how does histograms work? Okay, so the methods that you are going to use are going to be slightly different than what you used in your IGCSE O levels. Okay, so first rule in using histograms, now when we are working with data, we work with two types of data. What are they? We work with discrete data and we work with continuous data. So when it comes to histograms, histograms are supposed to be used only for grouped continuous data. So do you recall grouped continuous data from the previous lesson? So which means you have data, but they are in groups. So 10 to 20, 20 to 30. Likewise, you have data in groups. So grouped continuous data can be represented in a histogram. Generally, a histogram gives a good picture of how the data are distributed. So basically, just by looking at the histogram, you can see how the data is distributed. It enables you to see a rough location, the general shape, and how spread out the data are. Okay, so now this is a really important thing here. Over here, they say in a histogram, the area of the bar, can you see in a histogram, the area of the bar is proportional to the frequency in each class. So this is actually one of the main rules that we are going to use. Okay, what is the main rule? The area of the bar. The area of the bar is directly proportional to the frequency. Can you see? In a histogram, the area of the bar is proportional to the frequency in each class. This allows you to use a histogram to represent group data with unequal class intervals. So, in histograms, okay, there are several important things. First thing is the histogram, you can have, bars with different class intervals. Okay, so, and also the other thing is in the histogram, you need to remember there are no gaps in between bars. So, the place where one bar ends, the other bar should immediately start. Do you understand? There should be no gaps. Okay. So in a histogram, to calculate the height of each bar, do you recall this called the frequency density? So in your O levels, in your IGCSE O levels, you might have you were using this equation with frequency density. Okay. So in a histogram, to calculate the height of each bar, the frequency density, use the formula area of bar equal k times frequency. I think this is not the equation you were learning though. Okay, but this is the main equation that you will be using now. Okay, so what we do here is, how did they get area of bar equal k times frequency? How did that come? You can see here that we know the area is directly proportional to the frequency, right? So how do you remove the proportional mark? You put the equal mark and you put, when you're removing the proportional, you have to put a constant, right? So k times frequency. Area equals k times frequency. Okay. Area equals k times frequency. All right. And then they say k equal 1 is the easiest value to use when drawing a histogram. If k equal 1, then frequency density is equal to frequency over class width. I think this equation you might recall it from your IGCSE O levels, isn't it? Frequency density equals frequency over class width. But they have told you very clearly that this equation is only valid if what? If k is 1. If k is 1, but that will not be the case when we are working with the sums that we are going to do in this particular book. Okay, so you won't always get the case where k becomes equal to 1. So in that case, in such situations, it's always best to go with what? Area equals k times frequency. So you need to go with this formula. So basically, frequency density equal frequency over class width is not something that we are going to use very often now. Okay, so that equation can only be used if k is 1. So that in most of the sums, that will not be the case. That was the case in your O levels. Okay, so now I want you to work with this formula. This is the main equation that you are working when you are working with histograms. So remember, what are the main rules you need to remember when you're working with histogram? Number one, the data must be continuous. So it's grouped continuous data. There shouldn't be any gaps. If there are gaps, you need to fix the class boundaries. Okay, you recall how to fix the class boundaries from the previous lesson. You have to fix the class boundaries. And then you have to also what? Mainly use the equation area equals to K times frequency. Okay, so this is the main equation that we are gonna use. And then the final point, they say joining the middle of the top of each bar in a histogram forms the frequency polygon. So if you join the middle of each and every bar, okay, if you join the middle of each and every bar, that gives you the frequency polygon. Okay. All right. So we are not going to be moving much into frequency polygon. Okay. So we are mainly focused on the histogram. Okay. So drawing the histogram and also calculating sums related to histogram. So let's go into some sums now. Okay. So we'll move to exercise 3A, question number 1. They say the data in the table shows the mass in kilograms of 50 adult pufferfish. Draw a histogram for these data on the same set of axes. Draw a frequency polygon. Okay, so if you're gonna draw the frequency, if you're gonna draw the histogram, in that case, we will actually go with what? We'll go with the K equal 1. In the sense, we will go with frequency density equals frequency over class width, because we will be setting the K value now. Okay, so we will go with frequency density equal frequency over class width. Shall we go with that? In that case, in the histogram, the y-axis is the frequency density axis. The x-axis is going to be this mass. So you need to what? Extend this table into one more column where you will what? Get the frequency density. Okay, so frequency density is frequency divided by the class width. Okay, so let's extend this into one more. Frequency divided by class width. Over here, the frequency is 4 divided by class width is 10 to 15, which means class width is 5. So 4 divided by 5, frequency density is 4 over 5, the decimal figure 0.8. The next one, frequency divided by class width. Frequency is 12, class width 15 to 20. Again, class width is 5. So 12 divided by 5. How much? 2.4. And the next one, frequency is 23, class width 20 to 25. Again, it's 5. So 23 divided by 5, 4.6. And the next one, the frequency is 8. And class width 25 to 30 means class width is 5. So 8 divided by 5, 1.6. And the next one, frequency is 3 divided by class width is again 5, isn't it? 30 to 35. So 3 divided by 5 is 0.6. Okay, so we are ready. We have the frequency density values. Frequency density will come on the y-axis, and you will mark the mass on the x-axis, and you will draw the histogram. So let's quickly draw it. Okay, so you can see I have drawn the histogram. So frequency density on the y-axis, the mass in kilograms on the x-axis. So over here, I have started it from this point 10. So 10 to 15, the frequency density is 0.8. So you can see I have taken all the respective heights, 2.4, 4.6, 1.6, and 0.6. Okay, so that's the histogram for the data. On the same set of axes, draw frequency polygon. So how do you draw the frequency polygon? To draw the frequency polygon, you have to connect the midpoint of at the top of each histogram. So at the top of each histogram, you go into the middle of each and every histogram. Can you see? Can you see? So this is the frequency polygon. You join the middle of each and every bar, and that gives you the frequency polygon. Okay. So this is the answer to question number 1. Okay, so let's move to question number 2. Some students took part in an obstacle race. The time for each student to complete the race was noted. The results are shown in the histogram. Give a reason to justify the use of a histogram to represent this data. What are we plotting once again? We are plotting what? The time for each student to complete the race. That's what we are plotting. The main variable here is the time. The time is on the x-axis. So why is it, what is the reason that we can go for a histogram here? Is it possible to always use histograms for all cases? No, I told you very clearly there is a very specific group. What is that? You can only use histograms for continuous data. So over here you can see this is what? Time, right? So you are measuring time. Time is continuous. Therefore, it is okay, it is justified that you can use a histogram. Okay, you can't use histograms all the time, but only in the relevant places. So the reason is time is continuous. Part B. 90 students took between 60 and 70 seconds to complete the race. Okay, 90 students took between what? 60 and 70 seconds. I think you can see the bar between 60 and 70. So in this bar, there are 90 students in this bar, 60 to 70. So they say find the number of students who took between 40 to 60. Okay, so in this 40 to 60 bar, how many students are there? That's what they want you to find. Okay, so how do we do this? So what you do here is you can go for area equals K times frequency. So we'll go with the bar that we know. It's the bar that we know. The one with the 60 to 70, we know the frequency, right? Frequency is the number of students in that bar. So what's the area? Length into breadth. So length is, okay, so the length and breadth, so how much is it? 60 to 70. So what's the length here? Because it's 60 to 70, the length is 10 multiplied by what's the width here? The height, it's 6. Can you see? So we will use the frequency density. 10 into 6 equals K times what's the frequency? Over here, the frequency is 90 because there are 90 students in this particular bar. And that gives me the K value. This is 10 into 6 is 60 divided by 90. So K equals how much? 2 over 3. Get the exact figure. Do not go for the decimal because we will be using this K value for the other bars as well. So use the exact. K is 2 over 3. Now, what are we supposed to do? This K value, remember, it's a constant that is valid throughout the entire histogram for this particular sum. For this particular histogram, the K constant is valid for all the bars. Okay, when you find for one, it works for all the bars. So now they are asking us how many students are there, how many students took between 40 to 60 seconds. So basically they are asking the frequency here. So how do you do this? Again, you go area equal K into frequency. So area is length into breadth, which is 40 to 60, which means 20 into, what's the height here? Is it 4.5? Check clearly again. It's 5, right? Between 4 and 6, it's exactly in the middle. So it's going to be 5. So 20 into 5. Guys, I hope you can see this properly. So it's length into breadth. So it's 20, 40 to 60. It's a gap of 20. Here it's 5. So 20 into 5 equals K value is known now. K is 2 over 3 into frequency. Frequency is what we are trying to find now. So 20 into 5 into 3 over 2 equals to frequency. So multiply it, give everything in the cal. How many students are there? 20 into 5 into 3 divided by 2. That's 150, right? So you have 150 students in who took between 40 to 60 seconds. So you can give a conclusion. Okay. Okay, so then we'll move to part C. Find the number of students. Find the number of students who took 80 seconds or less. So basically what 80 seconds or less means you have to consider from the beginning. From the beginning, those who took 80 seconds or less. So how many bars are there for 80 seconds or less? But you can see we have how many bars, how many categories. So 0 to 60 falls under 80, 60 to 70 also falls, 70 to 80. Can you see that all of these bars that I have selected so far, they come? So find the number of students who took 80 seconds or less. So these are the 3 bars, right? You get these 3 bars where the time taken is 80 seconds or less. Do you agree? Okay, so all you got to do is now what? You have to get the frequency of all the 3 bars and add. But I think already you can see we know the frequency of 2 of these bars. We know the frequency of the first bar is 150, second bar frequency is 90. All you have to do is to find the frequency of the third bar and add everything. And when you add the 3 frequencies, you will get the answer for part C. Okay, so let's get it. Okay, so in part C, we need to just find the number of students in the bar from 70 to 80. That's it, right? Okay, so let's get it. Okay, so we are supposed to find the number of students who took 80 seconds or less. So basically the number of students in these 3 bars. I know the frequencies in these 2. All I need to do is to get the frequency of the third bar, which is, so area equals K times frequency. So area equals length into breadth, right? So how much is it? 70 to 80. The length is, it's 10 into how much is the height in this bar. So you need to be cautious here. How much did you use for the height? So I think you can see it's in the middle of the bar, isn't it? Guys, do you notice the height? It falls to the middle of this bar. So how much is it? So first of all, I think you need to find the value of one small square. So one small square, you can see 5 small squares represent 2 units. So if 5 small squares represent 2 units, then one small square represents 2 divided by 5, which is 0.4 units. Guys, do you agree? So then at this point, we know 8. So from 8, we have got one small square plus half of a small square. Can you see? You have gone one small square plus half. So one small square is 0.4 units. Half of a small square is 0.2 units. Can you understand? So that's really important that you take this height exactly correctly. Okay, so 8.4, and then another 0.2, that's 8.6. So this you need to clearly understand that this is 8.6. You need to clearly get it as 8.6. Okay, so 8, one small square 0.4, it's 8.4, another half of a square, that's half of 0.4, 0.2. So 8 plus 0.4 plus 0.2, it's 8.6. Okay, so then area is length into breadth. So 10 into 8.6. equals K value is known, right? 2 over 3 into frequency. So 10 into 8.6 into 3 over 2 equals to frequency. How much is the answer? How much? 10 into 8.6 into 3 divided by 2. So how many, how much? 129. Okay, and then let's get the total number of students. So how do you get the total number of students who took 80 seconds or less? So you have to add the frequencies in the 3 bar. The first bar has 150 students. The second bar has 90 students. The third bar has 129. Altogether, 369 students. Yeah, that's it. Okay, so that's 369 students. So that's your answer for part C. We'll move on to the last part. Part D, calculate the total number of students who took part in the race. How do you get the total number of students who took part in the race? Basically, you have to find the frequencies of the other 3 bars and also add. Okay. So, yeah. So in the third bar, we had how many students? We had 129. Okay, so we have 3 more bars to go, right? So let's go from the 80 to 85 bar. Okay. So you can see I'm doing this properly, naming exactly going as I go. So what's this one? Area equals K times frequency. So area length into breadth 80 to 85 means the width is 5 here. And the height, how much is the height? So this needs to be found properly. Yeah, I think you can see it is exactly 14. It is exactly 14, right? Yeah, the height is exactly 14. So 5 into 14 equals K is 2 over 3 into frequency. So 5 into 14 into 3 over 2 equals frequency. How many students are there in this particular bar? 105. So you can name here and write 105. Okay, then let's go for the next bar. 85 to 90. 85 to 90 area equals. So what is the area? Length into breadth, which is? Area is again 5. The width is 5. And what about the height? Is it exactly 12? Yeah, it's exactly 12. K is 2 over 3 into frequency is F. So how much is it? 5 into 12 into 3 over 2 equals to frequency. How much is the answer? 90. Last bar is from 90 to. So what is the area? Length into breadth. So you start from 90 and go until 120, which means 30. And what about the height? I think you need to, yeah, this goes in the middle, right? Yeah, so it goes exactly in the middle of 2 and 4, which means it's going to be 3. Equals K is 2 over 3 into frequency. So 30 into 3 into 3 over 2 equals to frequency. How much is the frequency? 135. Okay, so time to go for the total number of students. So total number of students equal. Yeah, just add all the students in all the bars. 150 plus 90 plus 120. I'm adding all the frequencies. 150, 90, 129, 105, 90, and the last bar is 135, right? Which is 699. So that's the total number of students. So 699 students took part in the race in total. Okay, so that's the answer. Okay, so we'll move on to question number 4. A farmer found the masses of a random sample of lambs. The masses were summarized in a group frequency table and represented by a histogram. The frequency for the class 28 to 32. I think you can see they're talking about this bar, right? 28 to 32 is the bar that I'm marking right now in green. So for this bar, they say the frequency is 32. The frequency is 32. Show that 25 small squares on the histogram represent 8 lambs. Okay. So how do we get this? The first thing you should do here is, we know that now here you have a frequency of 32, right? So you need to see for 32, to get 32 lambs, how many squares are actually there? How many small squares are actually there? Okay, so in this case, we will count the small number of squares. How do you count the small squares? Over here from 28 to 32, how many small squares are there? That's 10. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there are 10 small squares. And the other way, there are how many squares on this side, height-wise? There are 10 squares, right? There are 10 squares. So which means 10 by 10. So there are 10 small squares, which means altogether there are 100 small squares. So 10 times 10, there are 100 squares, and 100 squares represent how many? 100 squares represent 32 lambs. Can you see? So 100 squares represent 32 lambs, and they're asking us to show that 25 small squares, isn't it? They're asking us to show that 25 small squares. So how do you get 25 here? We should divide 100 by what? We can divide 100 by 4, right? If you divide 100 by 4, so divide both sides by 4 then. Isn't it? 100 lambs are 100 squares represent 32 lambs. So if you're dividing 100 by 4, you should divide the other side 32 also by 4. So 100 divided by 4 is 25. So 25 small squares represent 32 divided by 4, 8 lambs. So 25 squares represent 8 lambs. Can you see? So that's all. Just a simple explanation is all they want. Part B, find the frequency of the frequency of the m greater than or equal 24 less than 26 class. Okay, which one do they want you to find? They want you to find the frequency of the 24 to 26, this class. So how do you get the frequency in this particular class? We'll go with the number of small squares, because that's how we started with part A. The hint is given. In part A, we go with number of small squares. Then for part B, when you want to get the number of lambs, we'll always go with the number of small squares. Okay. So how much is it? Yeah. How many small squares are there? Can I have the area? There are 5 small squares lengthwise, right? 1, 2, 3, 5, and upwards 10, 15. That's 20, right? That's 20 small squares, which means area is 5 times 20. You have 5 times 20 squares, isn't it? So which means how many squares are there? 5 times 20 means 100. So definitely in the moment you know that there are 100 squares, you know 100 squares represent how many lambs? 100 squares represent 32 lambs. So in that case, there are 32 lambs. You don't even need to do any multiplication here because directly we know from part A, 100 squares is 32. So how many lamps did the farmer find the frequency of the class interval? So frequency of the m greater than or equal 24 less than 26 class. So what's the frequency? 32. Part C. How many lamps did the farmer weigh in total? How do you get the total number of lamps? So to get the total number of lamps, the best thing you can do here is let's actually what? Let's actually get all the squares, small squares, and you can actually go there. So from the 20 to 24, so we can go for 20 to 24. In the group 2024, what's the area? How many small squares are there? 10 by 10. So that's again 100 squares. 100 small squares means there are how many lamps? There are 32 lamps. Guys, do you agree? So this bar has 32. Then the next one, 24 to 26 is done, right? Is it? Find the frequency of the 24 to 26. Yeah, we already know it's 32. Guys, do you agree? So we know that this also has 32. 26 to 28, shall we get the area? So 26 to 28, what's the length and width? So we have how many squares? Width-wise, there are 5, right? 5 squares into what's the height? It's 5, 10, 15, 20, 25, 30, 35, 40, right? That's 40. So 5 times 40. How many squares do we have then? That's 200 squares. Guys, if there are 200 squares, how many lamps should there be? For 100 squares, there are 32 lamps, which means for 200 squares, there should be 64 lamps. So this is 64. For the class 28 to 32, we don't need to go for it because we already know it. In this class, the frequency 32 was already given. Do you agree? The next class, 32 to 34. In the class 32 to 34, how does the area go? It's 5 squares by. The other side, you have how many squares? 5. So 5 into 5, 25 small squares. So I think, yeah, we actually got it right, isn't it? So in the previous part A, 25 squares represent 8 lamps. They're asking us how many lamps did the farmer weigh in total. So total number. The total number of lamps is how much? 32 plus 32 plus 64 plus 32 plus 8. Do you agree? So I added the frequency 32, 32, 64, 32, and there is 8 lamps here. So which has to give you how much? It has to give you 168. Part C. Okay, so we'll move to part D. They say estimate the number of lamps that had masses between 25 and 29 kilograms. Okay, so they're asking you to find the number of lamps with a weight between 25 and 29. Okay, so how do we do this? I will erase all of these markings and actually mark what we require. So where is 25? 25 is exactly in the middle of 24 and 26, right? Okay, so between 25 to 29, 29 is exactly in the middle of 28 and 30, isn't it? So I want to find how how many what do you say? The frequency in these bars. Guys, are you with me? So I want to find the total frequency in these two bars. Guys, do you agree with me? Okay, so how do we do this? How do we do this? Okay, so the first thing is, I think when it comes to the bar 26 to 28, we did find the number of lamps, isn't it? In the 26 to 28 bar, there were 64. So I don't need to find this again. This one we know. So the only number of lamps I have to find is in the bar from where to where? From 25 to 26 and from 28 to 29. I think you can see 25 to 26 also. You can get it immediately. Why? Because you can see 24 to 26 is the full bar. 25 to 26 is exactly half the bar. So 24 to 26, there were how many? 24 to 26, there were part B answer, right? 24 to 26, there were 32. Part B only we found the number of the frequency in the 24 to 26. So there were 32, the whole bar. Since I'm taking half of that bar, do you get it? Since I'm taking half of the bar, the frequency should be, so in the 25 to 26, the frequency is half of 32. Guys, do you agree? How much is half of 32? 16. And then in the 26 to 28 bar, there's nothing for you to change. We have already found the frequency 64. Then what about the 28 to 29 bar? Yeah, actually, if you check 28 to 29, you can divide the whole frequency by 4. Because if you check, you can see that you can divide this into 4 equal sections. Guys, do you see like this? You can break this into 4 equal sections. Can you see? So in that case, you can just take the frequency of the 28 to 32 bar. What was the frequency of the 28 to 32 bar? 28 to 32 was 32. That was given, right? Yeah, it was given in the question. 28 to 32, frequency is 32. So 32 divided by, which is 8. So now add all the masses. So total 16 plus 64 plus 8. How much is it? 88. So in total, you have 88 lamps that had masses between 25 and 29 kilograms. Okay. So this is the end of question number 4. Okay. So next I'm choosing to do question number 6. Okay. So look at this. They say the variable y was measured to the nearest whole number. 60 observations were taken and are recorded in the table below. Okay, so you can see y 10 to 12, there are 6. So, okay, so 13 and 20, 13 to 14, there are 24 observations. For y values between 15 to 17, there are 18 observations. And for y values between 18 to 25, there are 12 observations. Can you see? They are asking you here, write down the class boundaries of the 13 to 14 class. What do you mean by the class boundaries? So if you recall the previous chapter, so you remember when it comes to these kinds of continuous data, there shouldn't be gaps in data. You can see 12 here, 10 to 12. The first class interval is 10 to 12. The second class starts from 13 to 14. You can see 12 to 13, there's a gap. So if it's continuous data, normally the place where you end one class, the other one should begin. So do you recall what we did here to remedy this? That's where we go for the class boundaries. So class boundaries in this situation, what do we do? You have to, I think you can see the gap between 12 and 13 is 1, right? So what do you do here? You have to take half of that value. You have to go halfway. So what you need to do here is from the lower limit, we subtract half. And from the upper limit, we add half. Do you recall? So what are the class boundaries? So this is something that you need to remember from the previous lesson. So class boundaries. So class boundaries, how does it work? Yeah. Class boundaries are 13 becomes 12.5 and 14 becomes 14.5. 12 becomes 12.5, 14 becomes 14.5. A histogram was drawn and the bar representing the 13 to 14 class had, had a width of 4 centimeter and a height of 6 centimeter. Find the bar representing the 15 to 17 class. Find for the bar representing the 15 to 17 class, find the width and find the height. Okay, so how do we do this? They say here, the first thing is they have given you the width and height of which bar? They have given you the width and height of the 13 to 14 bar. So 13 to 14 bar in the sense, you know, it's not 13 to 14. We are writing it with the corrected class boundaries, which is what? 12.5 to 14.5. So from 12.5 to 14.5, the class width is 4 centimeter and the height is 6 centimeters. So the question is they are asking what's the width and height of which bar? The 15 to 17 bar. Guys, can I know what's the 15 to 17 bar, the corrected class boundaries? 15 means it's 14.5 to 17.5. You know, you have to fix the class boundaries. Okay, can I also have the class width? So what is the class width in the 12.5 to 14.5 bar? What's the class width? Subtract the two because we want to get the width of the class. 12.5 to 14.5, what's the class width? 2. Okay, so I'm supposed to get the width W, height H, and what about the class width of the 14.5 to 17.5 bar? 3. Okay, so basically the question here is this. If a width of 4 centimeter is given for a class width of 2 units, can you see? Because 12.5 to 14.5 it has a class width of 2 units. So for that 2 units, you are assigning how many centimeters? You are assigning 4 centimeters. So if you are giving 4 centimeters here, then how many centimeters are you giving for what? For a class width of 3 units. So how do you do it? It's like a ratio, right? You can go for proportions. You can go for proportions. So 4 centimeter is represented by 2 units. So W centimeter is represented by 3. Okay, so yeah, so 3 times 4 equal 2 times W, which gives me W equals 3 times 4 over 2. So W is 6 centimeters. So width is 6 centimeters. Can you guys see? This is how you get the, basically width is, the centimeter width is proportional to the class width. Okay, that's done. How about the height? How do we go for the height? Yeah, the thing is height comes with the height of the bar comes with the frequency density, isn't it? The height of the bar comes with the frequency density, which means for this you have, and you know now in these cases you can't always assume k is 1. You can't immediately go frequency density is frequency over class width also. You need to get the k value. So in these situations we will go for what? Area equals k. Okay, area equals k times frequency. Okay, so we will go with that. Remember, why are we going with that? Because when it comes to the height of the bar comes with the frequency density, isn't it? So we'll have to get the height definitely by using what? The area equation. So how does the area equation go? Area equal K into frequency. So let's actually get the area for the 12.5 to 14.5 bar. So what is it? From 12.5 to 14.5, how do we get the area? The width and height are given, right? 4 centimeter and 6 centimeter. Multiply. 4 times 6 gives the area. Do you agree? 24 centimeters square. K times what's the frequency? In this particular bar, the 12.5 to 13.5 is this one, right? 13 to 14. 12.5 to 14.5. The frequency is 24. Can you see? So K equals 24 divided by 24. Actually, K is 1. K is 1. So we'll anyway use this equation again, which means area equals K is 1. So that is basically 1 times frequency. Guys, are you with me? So area is in the second bar The W value, we just found it to be 6 centimeters. So it's going to be 6 into H equals 1 times frequency is 18. And the 15 to 17 is the 14.5 to 17.5. So H equals 18 divided by 6, which is 3 centimeters. Can you see H is 3 centimeters? So this is something that's really important. When it comes, if you get a histogram question in the paper, so this is something they definitely test in all the histogram questions. So you will definitely get the beginning of the question looking like this, where they give you the width and height of one bar in centimeters and ask you to use that scale to get the width and height of another bar in centimeters. Okay, so this is something that you definitely need to understand and you need to remember. Okay, so it definitely comes up in the histogram questions in your exam.